Good afternoon. In today's video, we are going to be covering the IXL assignment on converting between standard and scientific notation. Before we jump right into the examples, let's take a moment to review some notes. First off, what is scientific notation? Well, scientific notation is a notation, so a form of writing numbers. Typically, it's if we have a really, really large number or a really, really small number, it would be extremely difficult and lengthy to write and pronounce. Therefore, scientific notation comes in handy. And one of the reasons it's called scientific notation is this is often used when working with science. So just one of many connections where math and science are related. Okay, right here we have a general example of what scientific notation is. A times 10 to the nth power. And this, because it's just the general template, we used variables. But let's talk about what each one of these pieces mean. The A is what represents a number. Now, in order for it to be written in proper scientific notation, that number needs to be equal to or greater than 1, but less than 10. So it has to fall between 1 and 10. In scientific notation, this is the one time that we will be using x's for multiplication because that's part of the form. And 10 will always be the base. And that's because that is what our number system is based off of, is it's a base of 10. And the n is an exponent. And that exponent could either be positive or negative. And in just a moment, when you see our examples, that we're going to go over why it needs to be one or the other and what each one means. Okay, let's first talk about how we go from a number in scientific notation and convert it to standard. Right here, we have a number in scientific notation. I know it's in that format because it matches what we just saw. This number out front, 3 42/100, falls between 1 and 10. And then it's written times 10 to the 4th power. We're going to focus on the exponent, okay? That exponent of a 4 tells us two things. One, because it's a positive number, it tells us that in standard form, so in regular format, this is a large number. It's a positive exponent, a large number. Second, if we visualize a number line, my positive numbers are to the right, which means to convert, we are going to be moving our decimal point to the right. So that exponent is really the biggest part. So the exponent is a 4, which means our decimal point is going to be moved 4 units to the right. And that is how we can convert it out of scientific and into standard. So here we move it 1, 2, 3, 4 units to the right because it's a positive 4, which gives us a large number of 34,200. All right, the flip side of that is we could have a negative value for our exponent. This time, we want it to be a negative value, unlike previous lessons with exponents, because this negative tells us that 1, it started off as a really, really tiny number. And 2, once again, if you picture that number line, all the negative numbers are to the left, which means to convert this to standard form, we need to move our decimal 4 spaces to the left. It's a negative 4, so we're going to go 4 spaces to the left. Starts off here, 1, 2, 3, 4 units to the left, and it gives us that decimal point that I honestly can't pronounce, which is why scientific notation comes in handy, because we take really large numbers, really small numbers, and we put them in a format that's easy to write, easy to pronounce. Now let's do the flip side. What if you're given a number in standard form and you need to write it in scientific notation? Right here we have a number, it's not too large, but 567 89/100. In order for it to be in proper scientific notation, our number needs to fall. It needs to be greater than or equal to 1 and less than 10. Does that number fall between 1 and 10? No, it doesn't. So what that tells us is we need to move our decimal point so that way it is written in such a way that the number falls between 1 and 10. And if we're going from standard to scientific, it's kind of that backwards movement. But we just got a little bit of logic here, because if I moved it to the right, is that going to make my number bigger or smaller? It's going to make it bigger, but I got to shrink it if I want to make it fit between 1 and 10. So instead, we got to move it to the left. All right, let's clear this so we can see what that is going to look like. Okay. So it was here, but in order to get into proper form, we had to move it 2 places. 2 places is how much I moved it. So the 2 is our exponent, because that's how many times we moved the decimal. And if we now look at our number right here, it's 5 and 6,789. That falls between 1 and 10, doesn't it? Yeah, because it's 5 and something else. So the trick here is you got to move your decimal point till it's right after that first non-zero digit. And then the number of places that you moved it becomes your exponent. And one of the best things I remember is if it was a large number, it's a positive exponent. If it was a small number, it's a negative exponent. Let's look at one more example. Right here we have a decimal. I mean, they're all decimals, but we have a small number because it's 0 and 432. Once again, in order for it to be in scientific notation, our value has to fall between 1 and 10. Right now, this is less than 1. So I need to move my decimal point. A little bit of logic here. If some of these rules and which way you move things confuse you, focus on small numbers, big numbers. If I move this decimal point this way, is that going to make my number fall between 1 and 10? No, it's just going to make it smaller. But if I move it this way, it will. Now I only want to move it as far as I have to for my number to fall between 1 and 10. So if I move it once, I still got 0 and something. If I move it a second time, I now have 4 and something. Does 4 fall between 1 and 10? It certainly does. So I can stop moving my decimal point because I've moved it so that way it fits the requirements between 1 and 10. Another way of saying that is we move the decimal point until it goes after the first non-zero digit. And I moved it 2 places, which is why the 2 is our exponent. Now notice it's negative. It's negative because it was a really small number. So the small numbers are negative exponents. The large numbers are positive exponents. And I always emphasize that because obviously, if you go one way, it makes sense, it follows the number line. If you're undoing that work, it's the opposite, and I don't want that to confuse you. Okay, it is now time for us to switch over to IXL and do a couple more examples, because that is one of the best ways to get this, is just to see it and to practice it over and over again. That's why we have you do the IXL, so you can get lots of practice and you can master it. Okay. Here we go. On the left, I have the IXL screen, but on the right, I have a nice little picture right here, so we have that as reference, and you guys can use that until you've practiced enough that you're confident to do it on your own. Once again, the IXL assignment that we're focusing on is right here, converting between standard and scientific notation. Problem number 1, how do you write 550,000 in scientific notation? Let's go ahead and copy that down. And I'm not going to write the comma because I don't want to confuse it with my decimal point. But you can if you want to. And if I look at my little poster over here, it wants me to write it in scientific notation, which means I'm going to look at this second one down here. We're going from standard and writing it in scientific notation. Therefore, I need to move my decimal point so that way my number, my value, falls between 1 and 10. But I have a problem. I don't see a decimal point at all. Ah, yeah, there actually is one. We just don't write it if there is nothing to the right of the decimal point. There technically is an invisible decimal point right here, because I could add as many zeros as I wanted to the end of that, and it wouldn't matter, because to the right of the decimal point, if it's all zeros, it is not worth anything. So add that decimal point in, and now we need to move it as far as we need to go, so my number falls between 1 and 10. So I'm moving it 1, 2, 3, 4. Do I need to keep going? Yep, because that's a 55. 5 times. So I moved it 5 spaces. Now that I've determined that, I can write it in scientific notation. First step, write my number. So 5 and 5/10. If we look right here, I have 1, 2, 3, 4 more zeros. But do I need to write those zeros? Nope, I actually don't, because once you hit a spot where it's all zeros to the right of that decimal point like we just talked about, you don't need to. And if it's scientific notation, it's always times 10 as our base. And then your exponent is how many times you move the decimal place. How many times did we move it? Yeah, 5 spaces. And last but not least, I need to decide if it's going to be a positive or a negative. Well, my number started off large, therefore it's a positive exponent. All right, 5 and 5/10 times 10 to the positive 5. That's a lot of 5s. And we're good to go. Let's try another one. All right, how would you write 3 and 97/100 times 10 to the second in standard form? Ooh, so this time we are writing in standard form, which means we're going to follow these directions right here. It's given to us in scientific. We need to write it in standard. First, we'll copy the problem down. Okay. If I am converting, that means I'm not counting to see how many times I need to move the decimal point. I am looking at my exponent to tell me how many spaces. Well, my exponent is a positive 2, which means it needs to be a larger number. And in order to make it a larger number, we need to move 2 units to the right. So our decimal point's here. We're going to move it 1, 2 units to the right, which instead of 3 and 97/100 gives us 397. And when it's written in standard form, the times 10 squared disappears because I moved the decimal, so that's no longer needed. And there we have our final answer in standard form. And it's a large number, it's not huge, but it is at least a large number. Perfect. All right, let's jump up a level here. Ooh, look at this large number. So we want to write 400,000 in scientific notation. So we're going back to that. If it's given to us in standard and we want to write in scientific notation, we're going to follow those bottom directions. First, we're going to rewrite our value. I personally am going to write it without the comma because I don't want to confuse my comma with a decimal point. But if you guys are really have good handwriting and you know the difference, cool beans. Now, we need to move our decimal point so that way our number falls between 1 and 10. So first off, where is our starting decimal point? Yeah, you can't see it. We need to add it, and it's at the very end. All right. Which way am I going to move it? Well, if we're trying to get our number between 1 and 10, it wouldn't make much sense to move it to the right because that would just make it bigger. So we need to move it to the left. So 1, 2, 3, 4, 5. Oh, look at that. It's a coincidence. So we just moved it 5 units to the right. And if I put my decimal point right here, what does that number become? Yeah, just simply a 4. Because if everything to the right of that decimal point is all zeros, do we need to write them? No, we don't. 4 times 10, and then that exponent is how many times you move the decimal point. How many times did we move the decimal point? Yeah, 5 times. Last little check, should it be positive or negative? Well, it started off as a big number, which means it's a positive exponent. What would it be if it was actually a little number? So like little in value. Yeah, it would have been a negative. Excellent. All right, we'll do one more. Actually, no, I want to do one where we have to go from scientific to standard because we've only done one of those. Let's go ahead and try this one out. So maybe we'll do 2 more. I might change my mind. Because this is a pretty big number. So let's make sure we can do it with even larger numbers. 553,000. And then we have 1, 2, 3, 4, 5, 6 zeros. I just realized I didn't say that number right. My bad. But we want to write it in scientific notation, which means we are going to follow these bottom directions. We're going from standard to scientific. So first, add that decimal point. Second, we need to move it so that way our number now falls between 1 and 10. So I'm gonna count later. I got a lot of moving. All right, let's say I stopped right here. If I stopped right there, what would my number be? 553. Does that fall between 1 and 10? No, so I can't. Oh. So I can't really stop there. I got to keep going. All right, if I go to here, what is my number? 55 3/10. Still not between 1 and 10. How about here? Yeah, that'll be 5 53/100. That's the right spot. That is our winner. 5 53/100. But once we hit all zeros, I don't have to write them anymore. That's part of this process. Now let's count up how many times we moved the decimal point because I lost track. So we moved it 1, 2, 3, 4, 5, 6, 7, 8 spaces. We moved it 8 spaces. And why is that important? Because that's our exponent. The exponent tells us how many places to move the decimal. Will it be a positive 8 or a negative 8? It'll be a positive 8 because it was a large number, which equals a positive exponent. Oops, typo, be careful. Make sure you always double check your work before you hit submit. All right, now this will be our final question because I wanted to do one more of these. So we are given a number in scientific notation and we need to convert it to standard form, okay? We have 6 2/10 times 10 to the 1. All right, if we're given in scientific notation, we're converting to standard, that means we need to look at that exponent and that will tell us how many times to move the decimal place. It'll also tell us which direction, because if it's a positive exponent, remember it's a large number, and when we're converting out of scientific notation, we go to the right. If it were a negative number, that means it needs to be a small number, and we'd go to the left. But it's a positive 1, therefore I'm going to move it 1 unit to the right to make it a larger number, and 1 unit to the right gives us 62. And there's our answer in standard form. Got to make sure it's correct. And it is. Oh my goodness, I fibbed again. I keep saying it's going to be the last one, but then we get good examples. So this time, 100% certainty, this really will be the last one. We just haven't done many negatives. So we got to do a negative, right? Yeah, right. Okay. I'm not meaning to fib, there just keeps being such good examples that I don't want us to miss out on. And we are converting this to standard form, which means once again, we'll be following those directions. All right. If we look at our exponent, the exponent tells us what kind of number it is and how many times to move that decimal point. So the 7 tells us we need to move it 7 times. The negative tells us it needs to become a small number. Therefore, I'm going to move it to the left. So 1, 2, 3, 4, 5, 6, 7. Whew. I moved it way past my number. So what do I need to fill in? Yeah, those all need to be zeros. Yikes. Can you see now why we like scientific notation better? Because that would be so easy to miss a 0 if that's all we had to work with. Whew. Being said about missing zeros, be careful when you type it in to not miss any. So 1, 2, 3, 4, 5, 6 zeros, and then 2, 2, 2. Whew. Good, no typos, we are set. All right, as always, guys, I hope that this was beneficial to you and answered some of your questions. Now it's your turn to try this IXL on your own. If you're working on it, you're using these notes and you still have questions, send your teacher an email or come to some help sessions. Good luck. Bye.